So at this point, I'd like to run over this graph. I'm going to walk you through this in preparation for Kathy Dodson's presentation on En-ROADS. So on the left, we have temperature. We've sort of seen this before, increasing in Celsius degrees. And on the bottom, we have time from 2000 up to the end of the century. Now, this was the temperature back here. If we assume this green line was pre-industrial temperature, this is all increase above pre-industrial temperature. So right now, this blue line here is how far we've gotten in terms of increasing temperature since the Industrial Revolution. Right now, we've reached about 1.25 degrees. And the Paris Climate Accord goals are that we should not exceed 1.5 degrees Celsius, or at the very most 2 degrees Celsius, in order to save us from the most extreme impacts from climate change. So we're here now, and if we continue on with what we're doing, which is called the model of business as usual, and we go there to the year 2100, we would reach a point where we were 3.6 degrees Celsius above the pre-industrial revolution, or in Fahrenheit degrees, we'd be 6.5 degrees hotter. This would be devastating and cause a tremendous existential threat to human civilization. We don't want to be there. So at this point, I'm pleased to introduce Kathy Dodson from the Citizens Climate Lobby. She will be showing you a climate simulator developed by En-ROADS, which is the MIT Sloan School of Management in Cambridge, Massachusetts. And Kathy, I'd like you to take it away from here.
Thank you, Dr. Sukanik, for that great review on climate change and its serious impacts. Now that we've heard about the dire climate situation, I'd like to briefly show you some ideas on how to effectively address the existential threat of climate change. My name is Kathy Dodson. I'm a physical therapist with a master's in public health. And after hearing about the gravity of climate change, I wanted to do something, but I didn't know how I, as one individual and not a climate scientist, could make an impact on such a huge issue. I felt really powerless. A friend told me about an international group with a chapter here in Sacramento called Citizens Climate Lobby, which is a grassroots advocacy group working to create the political will for a livable world. I joined so that I could learn more and become involved. Through Citizens Climate Lobby, I learned about a climate simulator tool called En-ROADS, which took over 9 years to build. It was built by Climate Interactive, a not-for-profit think tank that grew out of MIT Sloan in Cambridge, Massachusetts. En-ROADS helps people see what really works to address climate change. En-ROADS has been used to brief US senators and representatives and their staffers from both sides of the aisle, the US State Department, and the UN Secretary General's office, among others. Because of my interest in the En-ROADS Climate Simulator tool, I completed their training program last December and am now considered a climate ambassador, able to give presentations on En-ROADS. So if you've ever thought, what can I do about climate change, or how can I make a difference? I hope I can give you some ideas in this brief look at En-ROADS. I'll start sharing my screen. So this is the En-ROADS page, and I know from experience how overwhelming it is. And today we're only going to look at a few small parts of it, so don't worry. I'll be using my cursor to direct your attention, so just watch the cursor. This demonstration will give you a small taste of what the En-ROADS simulator can do. We just heard from Dr. Sukanik about the serious effects of climate change and the goal of limiting the temperature rise by the end of the century to hopefully no more than 1.5 degrees Celsius and a maximum of 2 degrees Celsius. By the way, all the temperature measurements I refer to will be in Celsius, but you can see the Fahrenheit degrees here below. For the purpose of this discussion, you can think of Fahrenheit as roughly double the degrees in Celsius, if that helps. We see here a graph of the amount of greenhouse gases measured in gigatons of carbon dioxide equivalent per year that we are putting into the atmosphere this century, from 2000 to 2100. We see that if we continue business as usual, this line here, meaning that we use some solar and wind power and continue burning lots of fossil fuels such as coal, oil, and natural gas, we are on target to reach a very hot 3.6 degrees above pre-industrial temperatures. Remember that our goal is to limit the temperature rise to 1.5 degrees and a maximum of 2 degrees. So what can we do? Let's get started with the En-ROADS simulator and see what it can tell us on how to limit temperature rise. First, En-ROADS is a global model, not just for the United States or California, so we need to think globally when we use it. I want to show you the global sources of energy, which include coal, oil, natural gas, and renewables, such as wind and solar power, and carbon price. Now, what does putting a price on carbon mean? This means charging a fee to producers of coal, oil, and natural gas, which makes these fossil fuels more expensive. So we use more renewable energy and less fossil fuels, which just plain keeps them in the ground. This has the added benefit of cleaner air and big health benefits, which you'll hear about later from the other presenters. Just as we have the energy sources listed down here, we can see them represented up here by different colored lines and how much of them we are expecting to use throughout this century, from 2000 to 2100. The red line represents oil, and we can see that our use of oil steadily increases until about 2060 and levels off for the rest of the century. The brown line represents our use of coal, and we can see that worldwide, the use of coal steadily increases throughout the century. Coal is relatively cheap to mine and transport. The blue line represents natural gas, which is used for electricity, heating, and industry. And we see that its use also steadily increases over the century. The green line represents renewables, such as solar and wind power, and we can see that the use of renewables is expected to really begin increasing, well, right about now, and steeply increase throughout the century, so that by the end of the century, renewables will be the dominant source of energy. Okay, let's look at how we actually use the En-ROADS simulator to see the power of different policies. Look, for example, at this policy, electrification of transportation. We see that if globally we discourage the conversion to electric cars, buses, trucks, and trains, as I move the big dot along the line, a slider, if you will, we see that we're emitting even more greenhouse gases, represented by the blue line, and that the temperature has increased 0.1 degree to 3.7 degrees, and we certainly don't want that. If, on the other hand, we move it in the other direction, representing encouraging and incentivizing the use of electric vehicles, the blue line shows us that we will be emitting less greenhouse gases and the temperature would drop 0.1 degrees down to 3.5 degrees. So that's how the simulator works. Let's continue looking at electrification of transportation and now focus on these colored lines, especially the red one that represents oil and the green one for renewables. And if you're able, try and pay attention to the brown line of coal also. So what happens when we help electrify transportation? Watch what the lines do throughout the century. And I'll do that again. We see that the use of oil is greatly reduced because we're using less gasoline. And because we need more electricity, this encourages the use of renewables, which really increases. There's also a small increase in the use of coal because of the rise in electrical demand. This illustrates the beauty and usefulness of En-ROADS. It takes whole systems into account and calculates the effects of one change on lots of systems, such as coal, oil, and renewables, just as we saw here. Since we want to limit the rise in temperature to 1.5 degrees or 2 degrees maximum, let's look at the effectiveness of some other policies that build on this first policy change. Let's look at increasing the energy efficiency of transportation. This includes using hybrid cars, expanding public transportation, and making it safer for people to walk and bike. It also includes not only cars, trucks, buses, and trains, but also big cargo ships and planes. If we encourage this policy, watch what happens, excuse me, to the sources of primary energy. Let's watch that again. We see that the use of all energy sources decreases because transportation is more efficient and we're using less fuel. We also see that we're emitting less greenhouse gases and we've lowered the temperature by another 0.1 degree to 3.4 degrees. Watch what happens if we use electricity instead of fossil fuels for our buildings, appliances, and heating system. As an example of this, I just received a rebate check from my utility provider for $750 because I switched my gas stove to an electric one. So watch the sources of energy again. And we're going to electrify buildings and industry. And I'll do that again. We see that this encourages the use of more renewables and decreases our use of fossil fuels. We also see that we've decreased the temperature to 3.2 degrees, another 0.2 degrees of lowering. Finally, what happens when we add making our buildings more efficient by effectively insulating them and using energy efficient appliances in our homes and buildings? This section also includes factories switching to using more energy efficient machinery. Watch the sources of energy. We see that the need for energy from all sources goes down, again, because of increased efficiency. Now we see that the temperature decreases another 0.3 degrees down to 2.9 degrees. We see that by implementing all four of these policies, we've reduced the rise in temperature from 3.6 degrees expected down to 2.9, a 0.7 degree improvement. Still nowhere near our goal of 1.5 degrees, but we're on our way. In the interest of time, we'll stop here. I hope it's clear that if we address other policy areas, we could lower the temperature even further. As you've probably realized by now, not one policy change can reduce the temperature to only a 1.5 degree rise. We use the phrase, there's no silver bullet, only silver buckshot. We need to make changes in many different areas if we are to meet our climate goals. Now I'll quickly show you the most effective policies to address climate change. The big hitters, if you will. We've seen that most policies lower the temperature by about 0.1 to 0.3 degrees, and I want to show you what setting a global price on carbon does, making coal, oil, and natural gas more expensive. Watch what happens to the sources of energy. I'll do that again. Green is renewables, red is oil, blue is natural gas, and the brown is coal. When we put a price on carbon, we see the use of renewable energy increases markedly. We see that we are using less coal, oil, and natural gas. We also see that the temperature has been lowered by 1 full degree, from 3.6 degrees all the way down to 2.6 degrees. This is by far the most powerful policy change we can make to address climate change. Other powerful policies include reducing the amount of methane and other gases that we're putting into the atmosphere. Methane comes primarily from cattle, agriculture, and leaks from oil and gas industries. And we see if we do reduce that, we could reduce the temperature another 0.3 degrees down to 2.3 degrees. Finally, if we work on carbon removal technologies, such as direct air capture, and we really incentivize these technologies, we can lower the temperature another 0.6 degrees. We've reached 0.17 degrees. We can see that enacting just these three powerful policies, we've reduced the temperature rise to only 1.7 instead of the expected 3.6 degrees. This is in the range of our target temperatures of a 1.5 to 2 degree rise maximum by the end of the century. So what have we learned from this short exercise? We see that we need to take many actions to address climate change. There's no silver bullet, only silver buckshot. Secondly, some of you may have reacted with surprise, as I did, when I learned that some policies that I thought would be really effective didn't turn out to have that much of an effect. But they still are important to adopt, as we will need to do many things to lower the temperature. Finally, we see that putting a price on carbon is the most effective strategy to address climate change. This has been a very short introduction to the En-ROADS Climate Simulator, which I find incredibly helpful in comparing the power of different policies to address climate change. It lets me know where I can focus my efforts. And a big takeaway for me, and I hope for all of you, is knowing that there are definitely many policies that work to address climate change. Dr. Sukanik, can you please share the resources screen? I encourage all of you to use the simulator. It's free by going to the Climate Interactive website. You will be able to compare the power of the policies that you're interested in. And if you take all of the En-ROADS training sessions, you too could become an En-ROADS climate ambassador. If you want to become more involved in addressing climate change, go to the website citizensclimatelobby.org and check out the organization. Our Sacramento chapter is very active. Feel free to contact Dr. Sukanik or myself if you or your group would like to hear more in-depth talks on climate change and on using the En-ROADS Climate Simulator. Finally, Dr. Sukanik and I would like to thank Congressman Bera and his staff for this opportunity to present information on climate change and various policy solutions.